Hello world, microcats! How often have you run out of memory in your microcontroller? Would you like to expand the capabilities of your chip to store your pictures, sound, special settings and any information in general? In this case, we are talking about a SPI flash memory chip of the type W25Q64BV. This microcircuit has 64 megabits of data memory, can be written byte and page by page, read byte. As an example, the functions of obtaining service information, device identifiers, manufacturer are demonstrated. The touch keyboard selects a group of displayed graphic files already pre-recorded in the microcircuit memory. In order to at the same time evaluate the speed capabilities, these files are displayed on the screen. The delay between pictures is 2 seconds. Unfortunately, the camera is poor at capturing glowing objects. The color depth of the picture is 24 bit. The color depth of the screen is 16 bit. By the way, this is a flopper, a big Russian cat. Subscribe if you like big flopper. You can take a closer look. Ignore the pixelation and quality of a screen picture. In this case, the frame rate is important. She says how quickly you can change frames that are physically stored in flash memory and are always displayed in parts. In the future, we will work with GIF files to display a simple animation. At the end of the video, there will be a bonus about how the new stand for the microcontroller was assembled, and now we turn to the electrical part. And so, to assemble the entire device, you will need an Stm32 microcontroller. Nothing works without it. The Stm32 display is suitable for displaying the results. It has a resolution of 160 by 120 pixels. The controls are simple with a touch keyboard. Flash memory chip W25Q64BV. As I said before checking, graphic files were written to it. This can be done using the CH341A programmer. For convenience, the microcircuit is soldered into an SMD DIP adapter. Pay attention to the place where to connect the microcircuit to the programmer. Software and drivers as well as firmware and electrical circuit are available for free in the Telegram channel. For a detailed analysis of the operation of entire system, it is necessary to delve into programming. We include the necessary header files, in particular libraries for working with the display, delay functions and working with flash memory, interrupt prototypes, SPI buffers for display and flash memory, size of BMP files for a given resolution. Globally, we monitor the buttons of a touch keyboard, the function of displaying a group of files. Setting up clocking. We switch from the internal clock source to the external crystal resonator. We configure the PLL module, configuring internal bus prescalers. We allow the peripherals to be clocked. Configuring input-output. We configure the port C13 LED and the opto relay as push-pull. The pin frequency is 2 MHz. To work with the display, SPI is required. We configure the pins according to the datasheet and a reference manual. In addition, 3 pins are required for the display to work. We configure them as push-pull. Please note that SPI1 works with the display. To work with flash memory, SPI is required. We configure the pins according to the datasheet and a reference manual. In addition, for the flash memory to work, 3 pins are required. We configure them as push-pull. Please note that SPI2 works with flash memory. Dual or quad modes are not used. Touch keypad push signals are sent to 4 pins configured as input pull-down. Setting up a timer. Knowing the frequency of a timer bus and the divider for this bus, we get the clock frequency of a timer. We calculate the internal timer divisor. We get the duration of a single tick. We set the value of a reboot register cumulative account. The divisor of the dead time generator is 1. We do not use the event repetition counter. Works in a single start mode. Timer 3 is used for a delayed call of a function. We turn it on when it is necessary to call this function. Configuring SPI. The operating mode is full duplex, 8 data bits. The prescaler is 2. This high frequency is not guaranteed. The chip select line is manually controlled. Works in master mode. We associate transmission and reception with DMA channels. SPI2 is configured in the same way. We call a similar function for initialization and binding to DMA, setting up DMA. The second DMA channel works with SPI. We indicate the address of a data register. We indicate the address of a receive buffer size. The data sizes for the SPI buffer and register are 8 bits. Reception is not looped. The third DMA channel works with SPI for transmission. We indicate the address of a data register. We indicate the address of a transmission buffer, the size of a transmission buffer. The data sizes for the SPI buffer and register are 8 bits. Transfer is not looped. For SPI2, channels 4 for reading and 5 for transmission. They are configured in the same way as channels 2 and 3. EXTI setting. We indicate the EXTI line of a controller. We turn it on. We will work in interrupt mode, where trigger is set to the leading edge. We connect the line to the external input port. The other 3 lines are configured in the same way. Setting up interrupts. For DMA channels, EXTI controller timer 3, we enable interrupts. We indicate the necessary events for the interrupts to work. We indicate the necessary interrupt priorities. Priority 0 for the most important interrupt. The setup is almost complete. Let's move on to high-level initialization. We initialize the display. We turn to flash memory for service information. We get the identifiers and display their values on the screen. A small loading splash screen. We show the line menu. Do nothing in an endless loop. Interrupt channel 2 DMA. We check the event and clear the flag. When turn off the channel. Interrupt channel 3 DMA. We check the event and clear the flag. We wait for the end of the bus. Set the CS line when turn off the channel. Interrupts of channels 4 and 5 of the DMA module are similar to channels 2 and 3. Channel 5 sets the CS line for flash, not display. Delayed function for displaying pictures on the display. We check the global variable, and if it has a value from 1 to 4, we show this or that group of files. The delay between pictures is 2 seconds. Additionally, before showing them, highlight the menu item in red. After all this, draw the menu again. Since the size of the pictures is fixed, and they are in memory one after the other without skipping bytes or alignment, you can refer to the beginning of the picture using a simple serial number multiplied by the size of the picture. Interrupt from EXTI controller. We check the number of the triggered line, clear the flag. Next we change the global variable, write the line number from 1 to 4 into it. When we start timer 3, it will call the function of displaying graphic files. Interrupt from timer free. Check the event, clear the flag and disable the channel. When we run the delayed start function, consider the bmp.h file. It contains a description of the BMP files. This is done through structures. Thus, referring to the BMP file as a pointer to a structure, you can access all its internal information. Consider the spiflash.h file. It describes codes of instructions for receiving and transmitting data when we work with flash memory. The codes are taken from the datasheet on the microcircuit. The structure is issued an instruction. Additional functions to control special lines except for SPI. Various synchronous functions were required to receive service data, read and write. Asynchronous function for fast data reading. Primary initialization helper function. All written functions have been tested. Let's take a closer look at the quick read function. It must be passed the address of the read memory, the buffer for read bytes and the size of the buffer. We reset the CS line and manually transfer various parameters to the microcircuit. Mandatory clearing of the SPI flags, otherwise DMA will not work correctly. Now we configure the DMA to work with a custom buffer and just enable the channels. The flag of the end of receiving the specified amount of data will be the disconnection of channel 5. An external call function can keep track of this flag. Let's take a closer look at the function of driving a BMP file. It needs the address of the beginning of a file in flash memory. First, you need to read the headers of the file. There is an offset for the location of a pixel array. The picture size is not scaled. Configuring memory access. Set up a display rectangle, the whole screen. To work with flash memory and display, arrays for data are required. We use the array sizes in multipliers of the number of pixels per line, namely 160. Next, we work in a line-by-line loop. Cycle stages. Receiving data from flash memory, converting it into data for the display, showing it on the display, and so on. Since the fast reading function is asynchronous, while the display is showing a picture, you can read data from flash memory in parallel. And if your brain has not exploded yet, then as a bonus you can look at the process of assembling a new microcontroller stand. That's all, see you in the next video, subscribe microcat.